Lesson 3.9 is titled Weighted Averages, and there are really three topics altogether in our textbook: weighted average, mixture problems, and uniform motion. In this video, we're going to look at the first two, weighted averages and mixture problems. How are scores calculated in a figure skating competition? In individual figure skating competitions, the score for the long program is worth twice the score for the short program. Suppose Olympic gold medal winner Ilya Kilkuk scores 5.5 in the short program and 5.8 in the long at a competition. His final score is determined using the weighted average. So they took the 5.5, and that's only weighted as 1, plus 5.8 is weighted twice as much, so times 2, and they're going to take that sum divided by 1 for the first weight plus 2 for the second weight. So his final score would be 5.7. Ilya Kilkuk's average score is an example of a weighted average. The weighted average M of a set of data is the sum of the product of the number of units and the value per unit divided by the sum of the number of units. Mixture problems are problems in which two or more parts are combined into a whole. They are solved using weighted averages. Jerry likes to feed her cat gourmet cat food that costs $1.75 per pound. However, food at that price is too expensive, so she combines it with cheaper cat food that costs 50 cents per pound. How many pounds of cheaper food should Jerry buy to go with 5 pounds of gourmet food if she wants the price to be $1 per pound? If we let W equal the number of pounds of cheaper cat food, we can make a table. The problem asks how many pounds of the cheaper Jerry buy to go with 5 pounds of the gourmet food if she wants the price to be $1 per pound. So they used W for the I guess. So that's going to be our cheap. I probably would have used C for cheap. But that gives us a total of the mixed is going to be W plus 5 or 5 plus W. And they said the gourmet was $1.75 a pound. The cheap stuff is 50 cents a pound. And we want to pay a total of $1 for the mixture. So to find the price of each, we're going to multiply the number of units times the price per unit. So we know we're paying $8.75 for the 5 pounds of gourmet. 50 cents times W, 0.5 W, and then the total, so all together, we want to pay $1 per pound times 5 plus W. So summing up, there's our equation written horizontally. $8.75 plus the price of the cheaper is 50 cents times W, the number of pounds, equals the price of the mixed food, which we said was $1 times 5 plus W. Now usually when we're solving one of those, we'd really have something to distribute, but 1 times anything didn't do a whole lot. Okay, so I distributed, Now we want to get W on one side, so I'm going to subtract 0.5 W from both sides of the equation. And now I've got W on one side, so I'm going to subtract 5 from both sides of the equation. And finally, to get W by itself, divide both sides by 0.5, and I get 7.5, and my units were pounds. And it's always best practice to reread the original problem. They wanted us to find how many pounds of cheaper food should Jerry buy. Oh, there it is, 7.5 pounds. We're done. To provide protection against freezing, a car's radiator should contain a solution of 50% antifreeze. Daryl has 2 gallons of a 35% antifreeze solution. How many gallons of 100% antifreeze should Daryl add to his solution to produce a 50% antifreeze? They let G equal the number of gallons of 100% antifreeze to be needed, and we're making a table. So the problem told us we know we have 2 gallons of the 35%, and we're adding G gallons of the 100%, and so our total of 50% is going to be G plus 2 or 2 plus G, whatever floats your boat. Now in the amount column, we're doing the amount of actual solution we have. We've got percent times 2, so this is how much of the antifreeze, and this was 1 times G, and so our final amount, we want our final percent to be 50%, and we need to have G plus 2 gallons of it. Now, my general formula that makes sense to me on these, we always have percent times amount plus second percent times second amount equals final percent times final amount. So for us, we're starting off with 2 gallons of 35% plus G gallons of the 100%, which 100% is the decimal is 1, and we want to end up with 50% is our final percent we want to end up with, percent, right? And here's our 2 plus G, so 2 plus G is going to be our total gallons. So 2 times 0.35 is 0.7, and 1 times anything itself. 0.5 times 2 is, of course, 1, and plus 0.5 G. Now I want to get G on one side, so I'm going to subtract 0.5 G from both sides of the equation. So I've got 0.7 plus 0.5 G, and we subtracted 0.7 from both sides, so 0.5 G equals 0.3. Divide both sides by 0.5, which would be the same as multiplying by 2, dividing by 1/2. So we get G equals 0.66 of a gallon. Seems like a reasonable answer. The weighted average of a set of data is the sum of the product of each number in the set and its weight divided by the sum of all the weights.